yesterday, we just had to finish up these notes, this page and its examples, and we are all good to go. Tomorrow, our plan is we're going to take a little mini exit ticket on this stuff, and then you are going to have some time to do any retakes if you still need to do that. Okay, so yesterday we looked at growth and decay. We did that hot dog example of hot dogs doubling, and we did the bismuth example, and we're really just solving 4 steps. We're figuring out if it's growth or decay by reading. We're going to highlight, circle, underline our important numbers, which is the A value, the initial amount, the R, the rate, and T, which represents time. Then we turn our rate into a decimal by dividing by 100, and then we plug it all in and our calculator does the work. So let's take a look at number 2. Okay. The National Forest Foundation is planting a new forest. They start by planting 100 trees. The population of trees increases by 12.63% each year. Write the function for the number of trees in the new forest, then determine how many trees there will be in 20 years. Okay, so first things first, we are trying to figure out, are we using growth or are we using decay? Growth. That planting is kind of our key word, because if we are planting trees, then the number of trees is going up. So we're going to use the A times 1 plus R. Okay, let's figure out what's important. So in my problem, what was my initial amount? How many did I start with? 100 trees. That was my starting amount. And how much are my trees increasing each year? 12.63%. And lastly, we're trying to figure out how many trees there will be in 20 years. Okay, so those are the 3 things we need. Okay, so we said this is growth. So y equals A times 1 plus R to the power of t. Okay, we are using the growth formula. If you want a highlighter, yeah, there's one. Huh? Oh, they're right here. Yeah, you can have a highlighter. Okay, and now we're plugging everything in. My initial amount, A, was 100. 1 plus. And here's what gets people, the rate. In order to find the rate, we need to divide it by 100. Right now it's a percentage. To get rid of that, we divide by 100. 12.63 divided by 100 is 0.1263. 0.1263 to the power of 20. That is our time. So there is our formula. Okay, from here it's just simple as plug it all into your calculator. So I'll bring up the big screen. So we had 100 trees. 1 plus, remember it's plus because it is growth, plus 1263, the power of 20. This will tell us how many trees there will be in 20 years. We click enter. Now when we are rounding these problems, you always round down to the nearest whole number. Because can you have 0.149 of a tree? No. You either have a tree or you don't. So we're just going to say 1,079 trees. 1,079 trees.
That's the answer?
That is the answer. Okay, a couple more. Good to go. Example 3. One of the most important things you do here is before you call me over and you're like, TOCAR is a growth or decay, or what do I do? You read the problem a couple times. Because everything is right in the problem. The red panda population is falling.
So, in other words, decrease.
In other words, decreasing. There will always be a keyword somewhere hidden in your problem. Here, it's falling. So that all that word tells us is we are going to use the decay formula. We are going to use y equals a times 1 minus r to the t. This is an exponential equation that falls. Okay, and we know that just by that word falling. Okay, it's falling by 8.15% each year. Currently, there are 10,000 red pandas left on Earth in the year 2022. Write a function to determine the number of red pandas left in terms of t, and determine how many there will be in the year 2030.
This isn't true, is it?
In 2022, the red panda population was around 10,000, yes. I don't know, the rates that they are falling, I made up. But that is how many red pandas about are left. Yeah, I know, it's terrible. Very endangered animal. Okay, so let's plug everything in. The A value represents the starting population, so currently there are 10,000. Next, we always have our 1. This time it's minus because it's decreasing. And again, we don't want to plug an 8.15 in. We need to take our percentage and divide it by 100. 8.15 divided by 100. My rate is 0.0815. 0.0815. If the year is 2022, and I want to know how many pandas there will be in 2030, how much time has gone by? From 2022 to 2030 is how many years? 8 years. So we are looking at an 8-year time period. Okay, 2022 to 2030 would be 8 years, so that would be an 8. Okay, I'm going to pull up the big screen. Let's plug it in. 10,000 is our starting population. 1 minus the rate, 0.0815. And this is the power of 8 years. There is our exponential decay problem. So this is actually a way, one way that they measure population growth and decay in the real world. They use an exponential function. So if the pattern of red pandas falling continues at the rate it is, in the year 2030 there would only be 5,065. Again, remember we always round our whole answers down. You cannot have 0.6279 of a red panda. You either have a red panda or you don't. And we cannot just create half a panda to exist, so we round our number down. So that is 5,065 red pandas.
So 5,065 is the answer.
Yep, that is how many red pandas would be left if that exponential decay kept happening for that next 8 years. Which that means in 8 years the population of red pandas would fall they would almost cut in half, which is not good. They use exponential functions when they see a population of animals decreasing. They'll model its population by the rate at which it is decreasing, and this is one way they can help determine if an animal needs to be protected or if there's some type of action they need to take to stop the decay. So this is one way math is used to kind of stop things like that from happening. Okay, example 4. A shoe company has 1,000 pairs of shoes when they started the company. Every year, their inventory increases by 9.82%. Okay, we're going to write a function to determine their shoe inventory. How many pairs of shoes will the company have after being open for 6 years? Okay, so first things first, is it decay or growth? Growth or decay? Growth. What word gives it away? It is increasing. The inventory increases. If the inventory is increasing, we are going to model using exponential growth. Y equals A times 1 plus R to the power of T. Okay. How many pairs of shoes did we start with? 1,000 pairs. How much are we increasing by? 9.82% is our rate. And we want to know how many we will have after 6 years. Now we plug and chug. So 1,000 pairs of shoes. Always 1. This time it's growth, so we use a plus. And we need to take our decimal, 9.82. And we need to divide it by 100. If you forget to divide your rate by 100, you'll get some wacky answers. So if you ever get a wacky answer, it's probably because your decimal got a little wonky. 0.0982. And our time period we're looking at for this problem is 6 years. 6 years. All right, now we plug it in. I'm just moving the page up so we can see it in the calculator. Okay, make sure you know how to plug this in. 1,000 pairs of shoes. 1 plus the rate. 0.0982. To the power, we use the caret of 6. Again, we'll never have 0.23 of a shoe, so we always round our answer down to a whole number, even if it was like 0.99. We can't make more of a shoe, so we always round that big number, that whole number down. So 1,754. 1,754 shoes. Question? Not too bad? Easy peasy? Alright. Example 5. Flip the page. We're almost there, I promise. We're almost there. You guys are so quiet. Okay, let's take a look. Okay, we have a two-part problem. Here's a real-world example of how population control is done in places like national forests and protected land. Protected reservation has 500 rabbits whose population is increasing at a rate of 12.48% per year. Write the function for the number of rabbits after T years, then determine the number of rabbits after 7 years. Alright, we got growth, or do we have decay? What's that population doing? It is increasing, so we are going to use growth. A1 plus R to the T. growing, 1 plus r. Now let's start plugging everything in. How many rabbits do we have right now? 500 rabbits. Always have the 1, and in this problem it is plus because it is growth. It is growing by 12.48%, which we need to divide by 100. 12.48 divide by 100. Again, if you forget to divide this by 100, you will get a crazy, wacky answer, and you will know that you probably forgot to do this. 0.1248, and this is to the power of 7 because we want to know how many rabbits there will be in 7 years. Okay? We plug it in. 500. 1 plus 12.48 to the power of 7. Click enter. You see what I did? What did I forget to do? When I plugged it in, what did I accidentally plug in? See how I plugged in 12.48 instead of 0.1248? See how my answer is super wacky? Yeah, so, and see how my answer is crazy? I got this e to the 10th. That's how you know you messed up. Okay, so I'm going to do it again. 500. 1 plus 0.1248 to the power of 7. So when you forget to move that, or divide by 100, you will know. Your answer will be wacky and crazy. So 1,138 rabbits. We always round it down. 1,138 rabbits. Okay, that is how many rabbits we will have if this population continues to grow for 7 years. Now this is a big issue. And humans actually do a lot to control populations of animals or plants that are invasive. Okay? So what might they do in a circumstance like this? They might allow hunting of rabbits. They might introduce predators to an area. There's a lot of different things they do to control populations.
And relocation.
Relocation, yep. There's lots of things we do in order to control populations, not just of animals, but of plants and marine life, lots of things. So if we were to see a population going out of control, here is something that they might do. Okay? So after the 7 years, so now we are starting with 1,138 rabbits, the reservation introduced wolves, a predator to the area. Using the amount found from part A, which was the 1,138 rabbits, we're going to write a function for the number of rabbits after 2 years if the populations of rabbits are decreasing now by a rate of 6.19% per year. We'll see how these wolves, or we're trying to figure out how these wolves will affect those populations after 10 years. Okay? So if wolves are now in the area, what do you think is happening to that population? That population of rabbits is going to start going down. Look, it says it, decreasing. We are using y equals a times 1 minus r to the power of t. This is after the 7 years have passed. So right now, we have 1,138 rabbits. That's our starting amount. 1 minus the rate, but we need to make sure we take that rate, 6.19, and divide it by 100. 0.0619. We're trying to figure out how many there will be after 10 years. So 1,138, 1 minus 0.0619 to the power of 10. So let's see if those wolves did their job. After 10 years, the population of those rabbits is now 600. I'd say they did their job, huh? Now they're back almost down to their starting population.